Listen and quit talking. Be a jerk today if that's what it needs to be. Arithmetic sequence. You should have learned this in algebra. Abigail's probably learned it here in the last week or so, probably. I don't know. Have you guys done that yet? You haven't done arithmetic? You will. I thought for sure I've seen you doing it at one point. I think you did this before that. What's your question, Alyssa?
Is it aromatic? Or
It doesn't matter. It can be pronounced either way. Arithmetic. Not, arithmetic would work. Not aromatic. That's a completely different word. Arithmetic sequence or arithmetic sequence. Either way.
It sounds like super smart, like undercover, like.
So on this, what you're going to do, you probably learned this when you were learning. This is why I was just saying to Abigail, when you learn slope-intercept form of a linear equation, you should have learned this before that. All right? This is what we do when we're just given a sequence. When you were given something like this with your x's and y's with two variables, it's sort of the same setup, but now all you're doing with the arithmetic sequence is one variable. I'm not going to have to move you today, am I, Alyssa? I'm getting ready to.
I'll be quiet.
So if we do something like this, 4, 6, 8, 10, this is just a real easy one. That's an arithmetic sequence. All right? It just goes in some kind of sequence. We could make that into a line, like you did with your x's and y's in the slope-intercept form, and graph it and do all that stuff. But this is where you should have started at. All you're going to do with this sequence is you're going to plug in here, you're going to plug in here. And what it's going to do, it's going to give you an equation for that pattern. So we can find any number in that pattern. We could find this 1,000th number in that pattern. That's all it does. All right? A1 stands for the first term in the sequence. So whatever comes first in the sequence. D stands for what's called the common difference. The common difference. The common difference just means how much it goes up or down by each time. So if we're looking at my sequence, what are we going to put in place of a sub 1? 4. That's the first number in the sequence. Plus, n is like our x. So it stays as a variable. Minus 1, that stays that way. Common difference. How much did I go up or down by? 2. Positive or negative? Positive. Now, where most people get confused with this formula is the 2's on the right-hand side of the parentheses. Does that matter? No. If you have this, that tells you to distribute. If you have this, it tells you the exact same thing. Doesn't matter which end of the parentheses it's on, it still is telling you to distribute. So I'm going to distribute, let's put this over here, this a sub n stays the same. We're going to distribute out here. We got a sub n equals 4 plus, what's 2 times n give us? 2n, good. What's 2 times negative 1 give us? Then we collect like terms. Those are our like terms. I'm going to put the n term first, just because it's usually better if the variable comes before regular numbers. 4 and negative 2 give you plus 2, good. That's our formula for that sequence. So if we wanted to find the 5,000th term in this sequence, guess what we'd put in place of n right there? 5,000. Instead of trying to write it all out, if I asked you to find the 5,000th term in that sequence, and Harry's sitting here going, 2, 4, 6, 8, or I'm sorry, 4, 6, 8, 10, 12, and he's writing all of them out until he gets to the 5,000th one, that's a waste of time. So we could use this formula to do that, and it looks like you get 10,002 would be the 5,000th term in that sequence. All right? Did I do something wrong? So that's all this is. That's an arithmetic sequence. Last year, probably after you looked at this for like a day or so, then you changed over, and in place of A sub n right here, you stuck in y. In place of n right here, you stuck in x. And you started writing stuff in that slope-intercept form. Okay? Arithmetic sequence more goes with something like this, where you just have one set of numbers. Slope-intercept form goes where you have like 0, 1, 2, 3, 4. Then over here you have 4, 6, 8, 10, 12, so on and so on. So you have an ordered pair. Same setup though. Does that make more sense on that page? Looking down at the bottom at the literal equations. Literal equations. Abigail, have you guys done any literal equations yet?
I think we're starting that.
Is that what you're starting?
I think so.
Literal equations. Forget this is here. All a literal equation is if you take some equation, like that equation that I messed up on the test, where it's supposed to be distance equals rate times time, and I had it written backwards or the wrong way, had the letters switched around. Distance equals rate times time. Maybe we're not looking for the distance. Maybe we're looking for the rate like we were doing on the test. We were actually trying to find the rate of the boat or whatever they were on the trip. So we're looking for the rate. Well, if I'm multiplying rate times time, how do I get rid of that t so the r is by itself? Divide by t. Everybody gets confused because you say, well, you ain't got no numbers. That doesn't matter. You're still doing the same process. These t's cancel out. What's left on the right-hand side? That's our new formula. That's a literal equation. When you don't have the numbers in there, you just have some kind of formula, and you want to get one of those variables by itself. You're just moving stuff around. I had a buddy, used to work over at Akey's. I'm not even sure what it's called now. All right, and no, it's not called Akey's. It's called something completely different. Yeah, it's changed names like 7 times in the last 10 years. But he used to be a big wig over there. Never went to college. He drove truck for a while after he got out of high school. Then went over to Akey's. Within a year and a half, he was one of the top people over there. All right, making 6 figures, about 5 times as much as I made after I went to college. Made me mad because he didn't go to college, and the whole reason he could do stuff like this. All right, they mix up formulas for the animal food, and if you can do this so that you know, hey, this time I want to mix in 700 pounds of corn with 100 pounds of calcium or whatever else, nutrients they put into this food for hogs and cows and everything else. If you can do this to know how much to mix for each different order that you have, you can make a bunch of money. All right, and that's all. He knew how to do that stuff because he's fairly smart. He knew how to do all that. 90% of the people over there didn't have a clue. When I was in high school, when I was here, and you guys probably wouldn't know them now because they don't live in the district anymore. Dunhams used to live up in El Dorado, and Rod Dunham was a math teacher over at Richmond. And I worked with him at, and we may have built some of your houses, at North Construction. All right? So I worked with Rod Dunham at North Construction. One day on our lunch break, we had to go out and set pins for houses. And all you do to set pins for houses is you drive stakes into the 4 corners, and it tells the backhoe operator where to dig the ditch for the concrete that goes under the house. The foundation, that's actually the footer. All right, so where to dig the footer. He got paid $75 for every house that he's setting. All right? Because you can't just go out in the field and put a stake here, then measure over here the distance that you want, and put a stake there, and then measure down here the distance that you want, and put a stake there, and then come over here, measure that over, put a stake there, and then you got your house. It doesn't work that way. What's going to happen with this last part right here? It's going to be not correct. Right? Might be too long, might be too short. What kind of angles do I have to have right here? You have to have 90 degrees. You have to have right angles every single time. And nobody else in the whole company knew how to do this. How to make sure that all four of those corners were right angles. And all we did, we set our 4 stakes, and guess what should be true about those two distances? They should be congruent. They should be the same. Using Pythagorean's theorem, if I do this, what should be true about these two triangles right here? The same. If I draw this, you got 2 other big triangles. They should be the same as the first 2. So we went through, in one lunch break, we did like 7 of these. So 7 times 75, it's 49, 52. For that hour lunch break, he made $525 just setting those pins because nobody else in the company knew how to do it, and they were willing to pay him $75. It took us like 10 minutes for each one, if that much. Guess how much of that $525 he gave me? No. Absolutely no. Page 64. Decide whether the syllogism represents correct or flawed reasoning. If flawed, explain why. Number 1. All triangles are polygons. Now, you probably don't know what a syllogism is. Guess what we're going to learn in this chapter? What a syllogism is. Syllogism. All triangles are polygons. Is that true? All triangles polygons? Yeah. Figure ABC is a triangle. So we know some shape is a triangle. Can we then decide that ABC is a polygon? Yeah. Number 2, no trapezoids are rectangles. So if you have a trapezoid, it can't be a rectangle. Some rectangles are squares. So if you have a rectangle, it could be a square. Some squares are not trapezoids. That's flawed, isn't it? All squares are not trapezoids, because all squares are rectangles, and we said at the beginning that a rectangle couldn't be a trapezoid. Alright, so syllogism is like when you say one thing, then you say something else, and those two things together lead you to a third thing. Alright? And I know that sometimes you probably use syllogism on your parents and say, well, if I do this, and then I do this, I should be able to do this. And they might say that your syllogism is flawed and not agree with it, right? That never happens, does it? Molly, that ever happened to you? Your parents just not agree with you? It does?
Oh, I thought you meant like they said that syllogism it's flawed.
Peyton, do I really think that your mom's going to say that syllogism is flawed, Peyton? Probably not.
Well, I don't know. Maybe you thought my mom was like some super educated scholar.
That doesn't. You don't have to be some super educated scholar to know this stuff, because I'm not. These are your notes for today. Might want to put chapter 2 at the top of them or something. Well, it already says chapter 2. This is the start of chapter 2. Make sure they get into your binders where they belong. All right? So make sure you don't lose them. Put them where they belong. We're going to go over them. We're going to jot some things down. Now remember, these are your notes. So Izzy sitting there, when we come to a statement, she might want to write something out next to a statement that helps her to understand it. That's the whole point of this. All right? Handle that, Sandra? The test, we'll talk about the test when we get done. Conditional statements, a conditional statement. What a conditional statement is? First of all, first thing I want to say about a conditional statement, it's also called an if and then statement. I guarantee that you'll see that on the test somewhere. A conditional statement is also called blank. And all you got to say, if and then statement. What a conditional statement is, says if John swims, then Sally talks. I didn't hear you quick enough, or I would have put it. That's a conditional statement. Now that conditional statement doesn't make a whole lot of sense. All right? You've heard conditional statements before. Dalton's heard his mom say, take out the trash like I told you, then I'll give you money for gas. She ever said something like that? No. She ain't giving you the money regardless. So a conditional statement. It's got an if part. If this happens, then we know this part. That's a conditional statement. We're going to learn how to deal with those conditional statements. A lot of stuff this chapter. This is probably the hardest chapter for teenagers in this whole book. So Ethan, very smart young man, he's probably going to have a little trouble with this because this is all about thinking things through logically, and that comes sort of later as your maturity kicks in a little more normally. All right? Don't run home and tell your folks, Mr. Harris so said we were little babies and not mature. It's not what I mean by that. It's just a common fact that you're probably not to your full maturity yet, right? Everybody understands that? You know, to write biconditional statements, make truth tables. Truth tables aren't very hard. We won't do a whole lot with them. This last thing right here, that's probably the most important. I guarantee on the final exam, you'll have a question. It'll say, write the converse, inverse, and contrapositive of this statement. I shouldn't even talk about the final exam yet. On the semester exam, you'll see something that asks you to write that.
I know what the inverse is.
What's the inverse?
It's Sally talks, John swims. No, probably not.
That's right. Or no? Say it again.
Sally talks and John swims.
No, that's the converse.
No, that's what I
The
mean.
inverse is if John talks, Sally speaks.
Maybe that's
No.
not it. No, I'm just joking.
If John doesn't, so Sally doesn't talk.
That's right.
There you go. That's what I'm talking about.
A statement. At least I think it was right. I didn't completely hear it all. I think so. A statement is any statement, whether it's true or false. So we make a statement. Doesn't matter what the statement is. Could be just a statement like, Alyssa's going to change seats here in about 5 minutes. That's my statement. Could be true, could be false. She should. Yeah, 'cause she
I
ain't
have
paying
been
attention.
quiet and.
No. I don't care if you're quiet. Dalton could be over there asleep, and he'd be quiet. That doesn't help me in the least. All right, Dalton, what do I want you to do?
You want us to pay attention and learn.
And learn. Learn. That's the main thing. Learn. Pay attention. Learn. A truth value. A truth value is just saying whether that statement is true or false. So if they ask you, what's the truth value of this statement? That's just asking you, same thing as saying, tell whether that statement is true or false. That's all there is to it. All right?
How is this math?
Because you got to think logically and think things through.
It seems more like English.
It's not really English because there's no logic in English.
It's more like common
It-
sense.
And that's what. How many times this year have you heard me say math is common sense? A bunch, right? Yes, I have. Maybe you haven't, but I have said it.
That's the class they really should be teaching.
Some kind of common sense class.
Yeah.
Why?
I would
A
guess-
negation. Shh. Back on track or we're not going to get done. You won't get to see your test. Negation. If you have a statement, and a lot of times, again, I'm pretty lazy, So instead of making up some long statement and writing it out, I'll just say our statement is P, or our statement is X, or our statement is Q. Just some letter to make it short. So if our statement is P, the negation of that would be not P. And we symbolize that. This is called the negation symbol. You might want to circle this on your paper there. You might want to do something with it. Maybe draw an arrow. Write the word not by it. Anytime you see that symbol, just the little tilde, it means not. So if you see this, it means not Tom.
Kind of looks like that. Like that about sign.
Yeah, so make sure you don't get it confused. You got that symbol, you got the approximately symbol, then you also have what we learned last chapter, the congruent symbol. Don't get the three of them confused. A compound statement. There, this is the English part. A compound statement is two or more statements joined together. When you're dealing with compound statements in English class, what words do we use to join them together? And, or, but, all those. In here, all we're going to use just two of them. All right? We're going to use and, we're going to use or. And is called a conjunction, or is called a disjunction. The difference in the two. If I say Tom and Joe, what's that tell us?
It's both of them.
Both of them. If I say Tom or Joe, what's that tell us?
Could be either one.
It's one or the other. All right? So a conjunction uses the word and, a disjunction uses the word or. This is the symbol for a conjunction. This is the symbol for a disjunction. So the upside down V, conjunction. Right side up V, disjunction. This one means and. This one means or. What we're going to do if we put stuff together, then you got to be able to tell, is that conjunction true? Is it false? So if I tell you this weekend, I am going to go to the movies and I am going to go to the grocery. That's a conjunction. I come back and I see you guys next Tuesday. And Ivy asked me, what movie did you go see? And I say, I didn't go to the movies. I went to the grocery. So now Ivy can run home and tell her folks, Mr. Ebersol's a big fat liar, because did I lie to her? Yeah, because I only did one of the things, and I said with the and, I said I was going to do both. So now I'm a little more careful now, because I didn't like Ivy called me a liar. So next Friday I say, I'm going to go to the movies this weekend, or I'm going to go to the grocery. Come back the following week and tell you, I went to the movies, I didn't go to the grocery. Did I lie to you? No. All right? So you got to be careful when you have a conjunction. Might want to write this down in there. When you have a conjunction, to be true, both parts must be true. For a conjunction to be true, both parts must be true. For a disjunction, do both parts have to be true? All right. So just one part must be true. Conjunction, both parts have to be true. Disjunction, both parts have to be true. I know Jacob's never, ever, ever used a disjunction on his parents, right? Never used a disjunction on your parents? Say, but Mom, or Mom, I'm gonna do this or I'm gonna do this. And you sort of lie to them a little bit because you know what you're gonna do, but you want them to think. You never do that?
So
Is that what it is? All right.
you only decide if they're a conjunction or disjunction after the fact, right? Because
If they give you a sentence, I don't know if I put any examples on here or not. No. There might be some on the back we'll talk about.
so because there isn't like a way to say that either one or both. Is there? It's either conjunction or disjunction.
Yeah, it's either a conjunction or a disjunction. It's either got the word and in it or it's got the word or in it. So it's got to be one or the other.
So it's not and or.
No. I guess you could put and or in there if you're trying to finagle somebody out of something or something, maybe when you start using that kind of language.
Okay, so with the disjunction, can you still like do both and it still be valid? Or?
Yeah. So, what Miss Carroll asked, if it says Tom or Joe, and both of them are true, is the whole statement still true? Yeah.
That was pretty much what I was asking.
Is that what you were trying to ask?
Yeah.
Yeah.
The
So if both parts are true, it's still true.
It would still be a dis.
Yeah, it's still a disjunction because it's had the word or in it from the beginning.
All right.
Conditional statement, we talked about this a second ago. Conditional statement's also called an if and then statement. An if and then statement. Very important that you know that. If and then conditional statement means the same thing. From here, this part right here that we're on right now, down to here, you might want to put some big asterisks beside all of this because this is going to be the most important stuff today. What a conditional statement is, and then on the next slide, the converse, inverse, and contrapositive statements. The if part of a conditional statement, the part that comes after the if, part that comes after, not the if itself, but the part that comes after it is called the hypothesis. You got to know that. So the part that's after the if is called the hypothesis. The part that's after the then is called the conclusion. So hypothesis and conclusion. So when I look at this, if P then Q, what's my hypothesis in this statement?
If P.
Just P, right? Just P. That's your hypothesis. What's our conclusion in this statement? Q. And Ginger's saying, well, that statement doesn't make any sense. And you're right, it doesn't. All right? It doesn't make any sense whatsoever. All we're doing is looking at hypothesis and conclusion. Just looking at the two parts right now. All right? And I've heard it about 4 times now. That's enough. This has nothing to do with science because science people, not always the brightest. What's it mean to be a hypothesis in science class?
Theory.
It's a theory. This isn't a theory. Our hypothesis is what we know to be true. All right? So we start off, we say, if this is true, that's our hypothesis, then we're trying to do whatever we're trying to see. All right, so if that's your hypothesis, then whatever your conclusion is. No, so you're still thinking science-wise, and that's not the way. Even if you ask the science teachers, that's not the way a hypothesis is supposed to be. So when we say something, you got that hypothesis first. You're looking at that and you're saying, okay, I know this. What can I decide from that? And that's what we got to make a decision on, whether the statement's true or false based on what comes after that. So if I say something like, if it is raining outside, then the sun is not shining. Our hypothesis is it's raining outside. Our conclusion is then the sun is not shining, or the sun is not shining. Is that true or false? It could be. So is it true or false? It's true some of the time. So what's that tell you? It's false. And that might be something you want to write down right here. How many things does it take to prove something false? Takes one event, we'll say, could be anything, event to prove something is false. How many events does it take to prove something's true?
All of them.
All of them. Thank you. Might be the first time in my 20-some years of teaching anybody's ever said that. All of them. So is it easier to prove something true or prove something false? False. You can find that one thing to prove it's false, the whole statement's false. So was there a day when it was raining outside and the sun was shining?
Yes.
So what's that tell us about our statement? It's false. All we need is that one. All right?
That kind of reminds me of, like, I think it's called like the black swan argument, where it was like Europeans for the longest time had never seen a black swan, so they just assumed that all were white. But then once they got to Australia, they had to rethink it. They were like, well, we can no longer say that.
So stuff like that. One example is all it takes, right? And then that proves that the whole thought was wrong. Let's look at this one. What's our hypothesis in this statement? This is going to be what your homework's going to be like. What's your hypothesis? Two angles are vertical. That's your hypothesis. What's your conclusion?
They
are congruent. Hypothesis, conclusion. If two angles are vertical, that's what we know. So we have these two angles. Angle 5, angle 7. And they're vertical to each other. No picture. I'm just telling you, angle 5 and angle 7 are vertical. Do we know that they are congruent? Yes? Yeah, because when I told you about vertical angles, what I tell you, it was always true about them. They're always congruent. So we know that this whole statement is true. We're not going to be able to go find the black swan anywhere where you have two vertical angles and they're not congruent. They're always going to be congruent. Does that part make sense? Harry, that part makes sense? Makes sense to even Sandra, she's soaking it in, osmosis. On your notes there, what I want you to do, take about 30 seconds somewhere on the side, write a conditional statement. I want you to write a conditional statement. So write your own conditional statement. Don't cheat off your neighbor. Write your own conditional statement. Could be anything, I don't care. Well, I do care. Don't make it something obscene or obnoxious. Didn't even have to say that, did I, Mackenzie? Everybody here knows better than that. Those of you who I don't see writing, those are the ones I'm going to call on to give you your conditional statement. If you can't get it, give it in 5 seconds, we'll make it a grade. Go. What are you looking at me for, Sandra? You think I'm getting ready to call on you? look like the evil eye. All right, Jason, give me yours.
If I think of something, then it will be true.
Does that work?
It's false then.
Nah, you don't know. Lauren, give me yours. Make up one.
I try one for her.
Sure, but she's gonna come up with one.
Probably this is one of my favorites. If I sleep, then they're awake.
Say it again.
If I sleep, then they're awake. Someone? Yep.
Anyone? Just kidding. I don't want to do that.
Wait on this. Do what?
Like, yeah, Ghostbusters, and they're like, oh, don't think of anything, and think of the next one.
Hey, beard.
Lauren, you get one yet? Come up with one. If something, then something. Come on. Like I told you guys at the start of the year, I don't know. It doesn't work with me, right? When I said that. Give me something, Lauren.
Actually, what was you saying? Is that
Something stuck in.
I got another one.
Hold on, Lauren's gonna give us one. Make up something. Let's go. Make up something. If this, then that. I don't care what it is. We'll wait. I'm not going anywhere. Yeah, go ahead. I'll let him give one while you're thinking again.
If it's 98 degrees outside, then it's hot.
It doesn't even have to make sense.
All right, Lauren, give us one. Make up something. You can come up with something. I have faith in you. All right. We'll let Peyton give one more while you are thinking, but then I'm not letting anybody else give any more.
If I don't know, then I guess.
That was good.
That was like philosophy right there.
All right, Lauren, give us one. Just make up something. It doesn't have to make sense. They told you that. It doesn't have to make sense. Come on, it doesn't even have to make sense. Just throw something in there. Say something. It doesn't have to make sense. Just say it. How? Because you're part of this class. So put it in the if and then form. Yeah, you could use that word. I don't care. Put it if and then form. I got Write down one for me and I'll walk back here and I'll read it for you. Make up something. Come on, let's go. Again, it doesn't have to make sense. Just pick two words, put one of them after if, one of them after then. It doesn't have to make sense. Just doesn't have to make sense. Just say it. What's the first word you're going to say? All right. Now say another word.
What kind of word is a room and just say it?
Say another word. Then what's your next word going to be? Then say another word. Make up another word. You made up something, make up something else. All right, I'll take that. You were saying I don't know every time, so I didn't know if that's what you were saying or not. Huh? Well, see,
That was like 10 minutes. 10 minutes.
So, conditional statement. Conditional statement. If, whatever, then, whatever. Again, it's just a statement. Do we care if it's true or false? Not unless they ask us about it. Now, we're going to make those decisions whether it is true or false. These are important. Very, very important right here. We already got this part up here, so you don't have to worry about it. This is the part that that's the part that we're worried about right here. Not the example there. That part right there, those three things. Write that down. Well, actually, you probably do want, or you already got it down, but these are the ones that we're going to look at. We probably do want to deal with that example. I put that example on there just as a easy conditional statement. If P, then Q. What's our hypothesis in this statement? P. What's our conclusion? Q. All you're going to do with converse, inverse, and contrapositive is it moves the stuff around and switches the statement up a little bit. All right? So if P, then Q, the converse moves the Q to there and moves the P to there. So moves the conclusion to here, the hypothesis to here. That's all it does. So all it does is switches. This is the part you probably want to write down so you can remember this. Switches the hypothesis, and I'm going to abbreviate, and conclusion. It switches the hypothesis and the conclusion. That's what the converse does. So if we go back up to this one, what's our hypothesis in that statement?
2 angles are vertical.
2 angles are vertical. What's our conclusion? They are congruent. Now, you do want it to sort of make grammatical sense. You don't want it to be some ridiculous statement when you start switching this around and you actually have a real sentence. So we want it to make sense a little bit. So when I switch this, what's it going to say?
If they're congruent, then 2 angles are vertical.
If they are congruent, then 2 angles are vertical. Now that's not very good grammar because what should come in the first part of the statement? Should a pronoun come in the first part of the statement? No, the actual noun should come, right? So maybe a better way to write that would be if 2 angles are congruent, then they are vertical. Right? Because if you wrote it, if you took this whole thing and switched it with that whole thing, your English teacher would say, no, you can't have they in that first part. In here, I really don't care. All right? So all it does switches them around. Inverse. The inverse negates both parts. Leaves it in the order it was in originally, but negates. What's negate mean again? Makes it the opposite, all right? Not. Negates both hypothesis and conclusion. negates them both. So mine here says if not P, then not Q. What if I go back to this sentence? What would it say if we stuck not in both parts?
If two angles are not vertical, they are not congruent.
Two angles are not vertical, then they are not congruent. Now you're going to have to start making decisions on whether those are true or false. If two angles are not vertical, that's the part we know. We got these two angles. They're not vertical to each other. Does that tell us that they are not congruent? Could I have this angle here, and they might still be congruent to each other? Yeah, and they're not vertical angles. So you got to be able to start making a decision whether it's true or whether it's false.
Well, just thinking about like your first example with John swimming at Sally talking. Does that mean if Sally stops talking, John drowns?
Contrapositive. Contrapositive. The contrapositive does both. Negates and switches. Alright? So it switches them around, switches the hypothesis and the conclusion, and it negates them. Negates both parts. Switches and it negates. What would the contrapositive of that two angles sentence be? Be careful, contrapositive is a little harder.
If two angles are not congruent, then they are not vertical.
If two angles are not congruent, then they are not vertical. Alright? The contrapositive is the hardest one to decide whether it's true or false. Converse, you can probably use your brain and decide whether it's true or false. Inverse, same thing. Contrapositive is a little harder, and I'm going to tell you this. You might want to write it down. If the original statement, and I can't write it there. If original statement is true, then that probably tells us that the contrapositive is true. So if your original statement, if this statement's true, about 99.9% of the time, the contrapositive is going to be true. So if Ethan has trouble deciding with the contrapositive because it's usually real wordy and sort of confusing, then go back and look at the original statement and say, well, that was true, so I'm going to guess this is true. Equivalent statements, we don't do a whole lot with equivalent statements. Equivalent statements are statements that have the same truth value. So if you got two statements and both of them are true, you say they're equivalent statements. If you got two statements and they're both false, you say they're equivalent statements. Biconditional, if I grab this book over here, every sentence in this book is biconditional. What kind of sentences are in this book? Definitions. All definitions are biconditional. And what biconditional means is the original statement is true and its converse is true. Alright, so if both the original statement and the converse are true, then the statement's said to be biconditional. And all definitions are biconditional. What's your question?
Oh, so for contrapositive, like if the converse and the inverse are both true, wouldn't that make the contrapositive true since?
Probably, yeah.
Okay.
Because it's like a
Because those are
Put 'em
both the-
together.
yeah.
truth table. If you look on the back page, looking on the back, we'll go back to perpendicular here in a second. These tables here at the bottom are called truth tables. Alright? If I give you a statement like if P then Q, and I say tell me whether it's true or false. Do you know whether it's true or false? No, because it's a nonsensical statement, right? But we can make a truth table for them to try to make a decision if it's true more times than it's false, or if it's false more times than it's true. and we'll talk more about truth tables here in a minute. Back on the other side real quick, perpendicular lines. You probably already know what perpendicular lines are. If you have perpendicular lines, they'll probably show you using that box. What's that box tell us again? Right angle. This right here is another way to show perpendicular. That's the symbol for perpendicular. So if I tell you this, somebody read all of that to me.
Line AB is perpendicular to line Q.
Everybody hear that? That's perfect. Line AB perpendicular to line QR. That tells us those two lines cross each other and they form what kind of angles? 90 degrees, right angles. If this is a right angle, what can you tell me about this angle down here?
Right.
It's a right angle also. How about this angle right here? Right angle. How about this angle? Right angle. So if those two lines are perpendicular, then we know all four angles are right angles, 90 degrees. Now on the back side. See how smart you guys are. I'm going to give you about 4 minutes to try these three problems. Does everybody know what a Venn diagram is?
Yeah.
You've seen Venn diagrams before? Can't read them on your paper. That's 25. That's 9. That's 11. Read these three and try to answer the three of them. We'll see how you do. All right, on this. Venn diagram shows travel methods for people in a particular company who travel for business. How many people travel by plane and train? Got to be real careful here. Notice. What's that word? And. So when we do that, here's where you got to be careful. We want the people who travel by plane and train. Remember when we said you use the word and, it's a conjunction. If it's a conjunction, what has to be true for the statement to be true? Both. Both. So how many people travel by plane and train? 9. Very good. 9. It's just the people in the green. That's the only people that make that a true statement. Next one, the number of people who travel by plane or train. You could put either one. Is it 45? Is that what it is? Do these people count? Yeah, because remember this is what, like Peyton was trying to ask me before that I couldn't understand what he meant. Just because Ann travels by plane and train, does she still make this a true statement? Yeah, because she travels by one or the other. Well, she actually travels by both, but she still makes it true. So this time, it's all of them, 45.
Wait, it can't just be like, you can't just pick one of those?
No.
Since it's plane or train?
It said how many people travel by plane or train. So we want all the people who travel by either plane or
It wouldn't make more
train.
sense if it said plane and train.
Now, if it said plane and train, then that's only these people that's in the middle here. The number of people who travel by plane and not train is represented, how many people travel by plane and not train? Plane and not train. Say it again. 25. Do these 9 people get included in that? No, because they're part of the train people. All right, on these truth tables. If you have a truth table, fill this in on your paper there so you understand these. These aren't difficult, and we're not going to do a whole lot with them, but don't make them harder than they are. If I have R here, do you know is R true or false? No clue, right? So this is what we're going to do, and we're going to fill all these in basically the same way. There's 2 different things R could be. It could be true, could be false. But then we have other parts of the statement, and we're going to have to deal with them. So I'm going to put a true here, a false here, a false here. Sort of forget this second column for right now. Let's look at Q. Do we know if Q is true or false? No. If R is true, Q could be what? Right, but let's do something different. True. If R is true, now tell me, Q could be what? False. You see what we're doing here? Here we have both of them true. Here we have R true, Q false. Here we have R false. Q could be true. We have R false. Q could be what? So all we're doing is making up all the different things that we could have. They could both be true. They could both be false. The first one could be true. The second one false. The first one could be false. Second one true. Again, do we have any idea whether R is actually true or false? Do we have any idea if Q is actually true or false? No. All we're trying to do here is get an idea of what's the possible outcomes. What could happen? What's this mean again? Not R. If we have not R, if we said R was true, then not R must be what? False. So what's going to go right here? False. How about here? How about here? Now we filled in all that. This is the statement that we're actually trying to decide whether it's true or false. Anybody read that statement to me? Not R, not R, and Q. What's that word "and" tell us? To be true, both must be true. So both true for the whole thing to be true. So I'm looking right here. We got not R, we got and Q. I'm looking at these two. Not R is false, that's true. Is the whole statement true or false? False. If not R is false, Q is false, what's the whole statement? False. Can't lie to your folks twice and then say, oh, okay, two falses make a true, right? That doesn't work. If this is true, that's true, what's the whole statement? This is true, that's false, what's the whole statement? That's what we're looking at, just that column right there. What percent of the time is that a false statement?
75.
75% of the time, that's a false statement. What percent of the time is that end statement a true statement? 25%. So if you had to bet, all the money you have in your pocket today, you had to bet whether it was going to be true or false, you'd probably be smart to bet on which one? False. Again, do we know what R is? Do we know what Q is? But we know 75% of the time this statement right here is going to be a false statement, even without knowing what the original statements are. Make your head explode, Ivy. Let's try this one just real quick. What's going to go in here?
True.
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 False.
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 False. We jump over here to Q.
True.
True. False. True. False. All right. Just so we have all the possible matchups here. Not R, what goes here?
False. False. True. True.
And all we're going to do is look at these two. What's that tell us again? That means or this time, right? So with or, what do you know?
It could be just one.
If one part's true, then the whole thing's true. So we look right here. False and a true. What's that tell us about the whole thing?
True.
True. False and a false tells false. True. True. What percent of the time is this statement true? 75%. What percent of the time is it false?
25.
1/4 is all I'm gonna say.
Huh?
I'm confused on the last column.
So this is what they're asking us. They're asking us, tell whether this statement is true or false. We can't make a exact decision on whether that's true or false because we don't know what R is, we don't know what Q is. But we can use this truth table do all this stuff like we did, and then pair these two up, and decide 75% of the time that statement is true, 25% it is false.
How did you get the key? Because last time if it was not posted.
Right. But when you have or, so if I said I am going to the grocery or to the movies tonight, and I only go to the grocery, I didn't lie to you, right? I told you, even though it was like a half truth. So with or, only half of it has to be true. With and, both parts have to be true.
If one's false, then don't.
Say it again.
If one's like.
Right, if it's and.
And then it's
So next time you're trying to get something over on your folks, make sure you use what word? Or, not and.
To get away with it without actually lying.
Looking at this one real quick. A hexagon has 6 sides. And 7 plus 4 equals 15. True or false? Oh, they already tell us on this one. That's false, right? Because it says and only part of it's false. We go down here. What you'll do on your homework, they'll tell you like P stands for this, Q stands for that, and you'll have to plug them in. This one says Q, so 5 is an integer. 5 is an integer. Is 5 an integer? So that's true. A hexagon has 6 sides. Is that true or false? True. It's got and in there, so what's that tell us about the whole statement? It's all true. A hexagon has 6 sides. True or false? True. And 5 is not an integer. True or false? False. This part's true, that part's false. We got and in there. That tells us the whole thing is false. Somebody read this to me real quick. Just this top part here. Not R and Q. So we got 7 plus 4 does not equal 15. 5 is an integer. First part's true. Second part is true. What's that tell us about the whole thing? The whole thing's true. With or, what's going to be different?
Only one has to.
Only one has to be true for both of them to be true. You can try those. I'm going to skip over a little bit of this. Oh, maybe not. That was the last stop. I thought there was something after that. Let's do this real quick then. Complementary angles have a sum of 90. True or false? True. If this is the word or, do I even have to read any farther? No. What's that tell me about the whole thing?
True.
The whole thing is
True.
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 Next one, 25 plus 100 equals 75. True or false?
False.
False. Vertical angles are a linear pair. Can vertical angles ever be a linear pair? No. So that's false. So what's the whole thing? False. Your assignments on page 71.